Hi folks, Mr. Long here. And I'm just doing a screencast. I'm finishing up the screencast on derivatives with radicals and rational exponents, fractional exponents. So I want to finish the example that I had just started, and so let's go through this. So remember that in the previous, when we did negative exponents, I could take that 3 right there and move it outside the derivative notation. I can think of this as 3 multiplied by um, the fourth root of x to the 6, and then I have to take the derivative of that. Or I can think of it this way as 3 derivatives of the fourth root of x to the 6. And that's the same thing, right? It's the same thing. It just makes it a little bit cleaner when I move that outside. And I should, of course, have my equal signs there. So let's go through this. And first thing I need to do is write this as a rational exponent. So what I should do is 3d by dx. And then in here, I'm going to write that as x to the 6 over 4. Now, I should know from my fractions, 6 over 4 is equivalent to 3 over 2. And I should simplify the fraction first before I start differentiating. My calculator, most calculators will do that. So it's going to be 3 derivatives of x to the 3 over 2. And now I can apply my power rule. Okay, my power rule. Oh, I'm not sure what that is. That's from something else here. Let's quickly get rid of that. Sorry, folks. Okay, let's go back to writing here. Okay, so now I need to apply my power rule. So 3 multiplied by, take that 3 over 2 and bring it to the front as the coefficient. Then it's x to the 3 over 2 subtract 1, which I'm going to write as 2 over 2. So I end up with 3 times 3 is 9. So I end up with 9 over 2 x to the 1/2, because 3 minus 2 is 1. But in the very end, I need to write that as a radical rather. And I know that x to the 1 over 2 is in fact the square root of x. So that it becomes 9 over 2 square root of x. Okay, and again, at any point in time, you rewind, look this over. You really should get these into your notes so you have a set of notes as well. Okay, and here's our last example. Find the slope of the tangent to this function right here. G of x equals 3 over root of x to the 5th when x equals 100. So this is, I'm evaluating the derivative. So this is g prime at 100. Okay, what is the slope of that graph? The IROC, the instantaneous rate of change. What is the value of the derivative? These all mean the same thing. The slope of the tangent, the slope of the curve at that point, the instantaneous rate of change, the IROC, they all had the same meaning. It's called evaluating the derivative. So substituting in 100 for the derivative. So first I need to write that with rational exponents, fractional exponents. So g of x equals 3 over x to the 5 halves, because it's the square root. Right? It's the square root. And now I need to bring that up to the top. So I can apply my power rule. So g of x will equal 3x to the negative 5 over 2. Okay, which now we can apply our power rule. G prime of x will equal. So what I want to do is take this and bring it to the front. It multiplies into the coefficient. So I have negative 5 over 2 multiplied by that 3, x to the negative 5 over 2 minus 2 over 2. This is a pretty tricky one. So g prime of x then equals, if I start simplifying here, negative 5 times 3 is negative 15. Negative 15 over 2. And that's going to become negative 5 over 2 minus 202 is x to the negative 7 over 2. And finally, I can rewrite that as a radical. The negative means it's going to go on the bottom. The 2 represents the square root, and 7 represents the exponent. So negative 15 over 2 root x to the 7th. Okay, and what I'm supposed to do now if I do it that way, actually what I'm going to do is this. I'm going to rewrite that. Remember, I can do this a couple of different ways. I'm going to take that, whoops, there, x to the 7th outside, because I want to get g prime when x equals 100. Negative 15 to square root of 100 all to the 7th, which will equal g prime at 100 will then equal negative 15 over 2 times by 10 to the 7th. And that's as far as I'm going to take it. I'm not going to simplify it any more than that. So that's a very, very steep negative slope, right? It's an almost zero slope, because 10 to the 7th is a huge number. So that's a slope of almost 0 when x equals 100. That probably means, by the way, there's a horizontal asymptote to this curve. Well, might not, you know what, it might not even be a horizontal asymptote, but the bottom line is that if you can think about that, this number is very small. So remember, it's a slope, right? There's your rise, there's your run. So in a rise of 15 over 2 times 10 to the 7th, 10 to the 7th is a huge number. So that's a slope of almost 0. And by the way, folks, that is it.